Okay, hello students. In this video, I'm making a video here. Thought of making this video because I felt there's a lot of confusion as how do we figure out increasing and decreasing of the transposition of functions of our original function f of x. So here is the lesson number 2.7, module 3, pima maths 188, pre-calculus 1, learning target. So what are you going to do here is create formulas in writing increasing and decreasing interval for transposition of functions of the type this. So each one of these I'll walk through and create formulas for this. How does transposition affects the increasing and the decreasing function? So I'm going to use the Desmos mm, uh, activity here. So I've taken one example. Let's imagine f of x is absolute value function, and I can see I did take the minus of this one, and at the same time I picked the interval from -2 plus 3. So at this time you must have already concluded as why did I pick this, because I just want to see if you see this red color, that's the graph of the absolute value function which is given shown here, and clearly it's the if you see, if I try to uh, I can if I want to see the original function, absolute value function here, and put maybe the original function is absolute value function, and that is I can put here x. Okay, there you go. So this V shape with the black color is the V shape, which basically because of this -1, it shifts one place to the right. Okay, and then I put minus outside, it flips over the uh, x-axis and reflects over the x-axis, and then there's +4 and it shifts to +4. So basically the red and the black is the same, except that I try to change the interval here from -2 to 3, and that's all I did. See, so I pick from -2 to 3. So let me take off this black color. I'm more concerned about only the red one, and clearly it is increasing function here. It's increasing from -2, that's -2 until 1. So you can clearly see the graph, the y values. You can see the y values, they go on increasing and until 4, and after that they go on decreasing. So we have increasing and decreasing interval from increasing from -2 until 1. So clearly the graph, this graph, so for this interval from -2 to this interval, it is increasing. So the graph is increasing, and we will make a table out of this. And then from 1 to 1 to 3, the graph is decreasing. So that's the main thing. So if I write this increasing and decreasing, so the original function, whatever the f of x given to x, that's increasing from -2 to 1, and then decreasing from 1 to 3. So this is the main thing. So we want to know let's do each time new transposition. So the first one, so I made another table. So here is the table is here. So the first one, I made a table right here. Okay, let me take this up here. Okay, so here is the first column. I made a table f of x, the original function, and you can clearly see it is increasing -2 to 1 and decreasing 1 to 3, right? So I'm creating a formula. So let's use P to Q and Q to R. And this is the same function that we have graphed this. So I'm going to do now next is we want to know how does this, so if I have a scale factor 2, so I'm going to take a is 2, the a is greater than 0. So let's go back there. Over here. So this time I'm gonna write down, let's see, 2 times. So the scale factor I'm picking is 2 times f of x. Okay, f of x. So okay, so you multiply 2 and you can clearly see there is a vertical stretch. So, and I'm gonna bring it down. So this was the original one. This is the original one. And clearly this original function increasing decreasing does not change, and you can see this is still it is increasing in the same interval and still decreasing in the same uh, interval. So what basically this means is the scale factor, if it is plus 2, or even if I can make half also, if I just put 1 divided by 2, and you can see there is a vertical compression by scale factor of half, and still it is increasing and decreasing. So all that we can conclude it, and that in the table, if you see the table that I made here, so here it is. So this does not change. So whatever -2 to 1, so increasing still the when you have a vertical stretch or vertical compression, it does not affect the increasing and decreasing interval. So this 1, 3 still stays 1, 3. So that's what we have made inference or made conclusion. What about if I try to instead of this, let's check on what about I make a vertical shift. Okay, so let's write f of x. Well, that's the original one, right? And then I put plus maybe 4. Okay, so maybe 3, 5, whatever, and you can clearly see the graph gets transport 4 units up, and so that means the if it is increasing, so the first time it is increasing and then it is decreasing, right? So both cases you can see it is increasing and then decreasing and then again increasing and decreasing, so the interval stays the same. So what I did was in the table, here is the table. See, in this example, I took plus 2. So, and that k plus k vertical shift, but k is plus 2. You see, the PQ and QR, they still stays the same. So, what is the conclusion is this vertical stretch or vertical compression, or you move the whole thing up or you move whole thing down also. The increasing and decreasing does not affect the class intervals where it is increasing, decreasing. I mean, the vertical stretch and the vertical shift does not affect. So let's see what happens. We'll do some changes now, and let me take this off here. And let's see how the horizontal shift affects. So I'm gonna do f of x and -3. What does this mean? We all know that if you have x -3, it means the graph shifts uh, to the right, 3 units to the right? So I can clearly see, let me change this color, press and hold, and to some different purple color. So the red graph that you see here, so the red graph that is increasing and then decreasing. The other graph that is a purple graph also is increasing and decreasing, but the intervals they changed. What I mean is, this was the original -2 to 1, it was increasing, and from 1 to 3 is increasing, but what you see now is there is a change in increasing. So you can see this is where it is, that's 1. Can you see that 1? It is increases until 4, and then again decreases until 6. Okay, so that means every time you're adding 3. So how did you get from this point? Okay, let me show with the help of, okay. so So this interval, which was in the beginning, this was the where it was increasing, but now it is increasing here, this part. So from -1, good now, uh, -2, sorry, -2 to 1, but now it is increasing this way. See, it is from 1 to 4, it is increasing. So how did we get from -2 to +1 here? So -2, this -2, you just have to add 3, because this point has shifted here. This point has shifted 3 units. So every time this point also shifted 3 units, because of the horizontal shift, the graph is shifted 3 units to the right. So all you do is each of those points. So each of those points, here it is. So there is x -3. So this x -3, I pick 3 is that means the graph shifts 3 units to the right. The h is 3, which is positive, and shift h places to the right. That's what I wrote here. And now it is, so you are adding +3 to all the to whatever the class interval that -2 to 1. So you're adding the so you're adding 3 and you're adding plus so 3 you're adding 3. So everywhere you are just adding 3 and you get you can clearly see this -2 plus 3 is 1, 1 plus 3 is 4, and that's how you get it. So just adding 3 and you're done. So that's what we learned is just adding the how many times you are shifting to the right. Or I could have put instead of -3, I could have put some -4 here. What will happen is minus of -4. So that means here you are subtracting -4. So instead of +3, you'll be doing subtract 4, subtract 4, subtract 4, subtract 4. So each time you're going to the left side. So I hope that helps. Let's go to the next one. Reflects over the. So I'm going to take this off. Let see how does f. So I put minus of f of x. And we know what does that mean is reflection. There's a negative. The output they become opposite. So if we have plus, if it is 2, so whatever, and you can clearly see, let me post here. So whatever this point is, now it is the y, the output plus 1. So it is plus, okay, let me click on it. So output 1 changes to minus 1. The output here 1 and 4, the 4 becomes -4 here. And clearly this one, even though I can't see it, it is 2 there output, but now it is -2. So what's happening is, so what conclusion can we make here? Okay, so let's see what is the conclusion we can make here is, so the graph was increasing in the interval -2 to 1, correct? So, but now the graph is this was increasing, but because of the reflection over the x-axis, so we did that f of minus, sorry, the minus of f of x. Now it is decreasing. So this is decreasing. Okay, so in increasing and decreasing, so it was -2 to 1 and it was decreasing 1 to 3. So what's changing is you just have to swap these class intervals. So this decreasing interval will be here. So for the new function, so this will go right here, 1 and 3, and this thing will go right here. So you just have to swap the intervals of increasing and decreasing. That's it. So what conclusion can you make from here? So let's go directly to the here. So that means minus of fx reflects over the x-axis. And you can see the color that I use. If you see this color that I So the green one was here, interval. This is where it was originally increasing, and this was originally decreasing. Now this pink color is right here. That's increasing now, and the one that was increasing first originally, that becomes decreasing right here. So the formula is all you do is if this is QR, this become QR comes here. If this is PQ, then this will go right here. That's all it is. So you just swap the intervals. That's what is the inference or the conclusion, or you make a conjecture, and minus of f x. Whenever there's a reflection over the x-axis, you can see increasing becomes decreasing and decreasing becomes increase. That's all it is. Now comes the next one. Okay, this time I'm gonna take off this minus here. I want to do reflect it over the y-axis, so minus it. So that's minus of. So what does it mean is the red graph, make it little thicker, so you can see the red graph. Ah, x equals, I missed something here. Okay, where is that? X equals, so the x equals, original was 3, so, sorry. Mhm. Uh, this is the one I want to make it dotted. Okay, and also so the red ones is just to know. So originally, you see, this was our original -2 to 1 and 1 to 3, right? So what changed now? Look at this. So the graph reflects over the y-axis. So reflection over the y-axis. So this extreme right now, look at this 3 2. This 3 2 now it is -3 2. Can you see that? So let me take this off. I don't want you to get confused with it. Let me take this off and okay, this is the one. This one is 3 2, right? Now it is -3 2. So that's where it's going on increasing until that point -1. So originally this was okay. Let me say this was 1 and this was 3, right? Now it is -3 here. So that's what is not it's missing. And let me put it like maybe I can put it x equals -3 to show that step. Okay, I don't want so thick there. Okay. Okay, now we can clearly see. So this point, which is right now, it shifts to this side. You can see that. And this point, which was 1 and 4, now it is -1 and 4. And this point goes to the right, goes right here. Uh, wait, hold on. So let me show here. I'll start with this. This is 1, right? That's 1, and this is 3. So and it was decreasing. So this was decreasing here, 1 and 3. But now, when you reflect it over the y-axis, see that's the y-axis. So this point, this is -3 now, and there you go. It instead of decreasing now, it is increases. See this graph? It increases until -1. So this interval, it was 1 and 3, but now it is -3 and -1. So basically, the decreasing becomes increasing, changes to increasing, and this +1 and +3 that you swap. So 1 and 3 get swapped -3 to 1 here. And also you have to switch the sign. That's the conclusion. So basically, let me write here. So in the beginning, increasing and decreasing. So this was -1 to 2, it was increasing. And 2 to, sorry, I made a mistake here. So -2 to 1, it was increasing. That's the original interval, and decreasing from 1 to 3. What changes is for f of -x is you clearly see now it becomes -3. So it is increasing here -3. So this answer is -3 -1. There you go. Here it is increasing. And then after that, you can clearly say I'm going to use maybe other color. So this was increasing from -2 to +1, but now it's decreasing here. Clearly, it is decreasing from this is the main step. This is the step, see, from -1 to +2. So that means I should write -1 +2. I want you to see, make a conclusion here is all you do is we don't have to sketch this all the time. You just have to say, okay, if it was decreasing here, you just have to swap the 1 and 3 get swapped 3 and 1, see, 3 and 1. But you have to also write plus and +3 become minus and minus. This -2 and +1, so you swap the intervals like -2 to 1 changes to 1 to 2, 1 to 2, but you have to also switch the sign. That's all it is. Clear that? So I made a conclusion here that f of -x, here it is. So if it is f of -x, it is reflection over the y-axis, and the the QR which you see, this QR now become -r minus. That's like a formula you create. So you just have to. So the conclusion we can make is right here. Look at this. So the this one QR. Look out. If this is 1 and 3, this become minus 3 minus 1. So all you do is swap this and switch the sign. And this one. So this gets switched and this also. So minus 2 1 it changes to uh, minus 1 2. So this is the conclusion I'm making, and you just have to write down here. So in the formula form, if this is PQ, you just have to swap P and Q and switch the sign also. And if this was decreasing in Q and R, you just have to swap QR to RQ and then switch the sign. That's all it is. Okay. And let's go directly uh, um, to the last, almost another one, which is minus of f of minus x. So I'm going to take this off. Okay. And just to avoid, I don't want, we know all this, so let me take this off. So this is the original one. And this time I'm putting minus of f of minus x. So what does this basically means? Then you can see what's happening is the graph, okay, let's check. So originally the graph was increasing till 1, right? That's where it was increasing, okay? So minus 2 to 1, it was increasing. Let's see what's happening is now it is also, so the same part, this one, 1 to, yeah, and now it is increasing, use a different color. And this time this is the point, right? This is the increasing, see? So the new graph, that means this thing is increasing. If you go all the way here, that's minus 1. So it's increasing between minus 1 and 2. So the minus of f of minus x, the new one, this one is increasing now in minus 1 until 2, right? See, plus 2, plus 2. And then decreasing. And for this, let me use the green color. Maybe I'll use the red color. So this was decreasing from 1. So that was 1 and 3. So that is plus 1 plus 3. But now it is decreasing. Here it is. See, decreasing from this point is minus 3. So that means this one until here, the red color. So this is where it is decreasing. So I'll have to write from minus 3 until minus 1. There you go. So this is how it changes. Originally, what was the original f of x was? It was increasing, and you can clearly see it was increasing. You can from minus 2, that's what we had always take minus 2, 1 was increasing. That was increasing. And the decreasing was from 1 to 3. And what change do you see from this to here? Is that this minus 2 and plus 1, now this is what you swap, okay, the endpoint, that is minus 2 to 1. So 2 1 becomes 1 and 2. The only thing, this plus 1 becomes minus 1, and minus becomes plus. That's all it is. And the same thing is for this one. So this is plus 3, now it is minus 3, and this is plus 1, and now it is minus 1. All you do is just uh, swap it, the endpoints, and switch the sign. So let's do conclusion about this is, and here it is. I'm gonna take this one right here. Okay, that means what I'm trying to say. I'll copy and paste it right here. There you go. So what did we learn from here is, watch this. These are the only two things I need to make conclusion. Okay. Now it looks nice and neat, right? So increasing, decreasing. This is the original one, right? And this, what changes is all you do is swap PQ become PQ is RNQ. Only thing it is plus P, which is plus P. This is plus P plus Q become. Uh, there's a slight mistake I did. Plus P plus. So the increasing, almost you are what all you do is this minus 2 plus 1 becomes minus 1 plus 2. See? And this plus 1 plus 3 changes to. So this is what you are going to swap and switch. This is what you're going to swap and switch for this. Now, what is this basically mean? What is minus of f of x is, it's like f of minus x is you're reflecting first, reflect over y-axis. And then after that, then there's a minus, then you reflect over the x-axis. Basically, this is nothing but is if you have something like this, okay? So when you have this is like a f of x, all you do is this part is reflect this part is let's see this is the thing that gets reflected over the y-axis first. So that's f of minus x. And then you again reflect over the x-axis. So this whole thing will now go like this. Okay. So this reflects over the x-axis. This is the one which is minus of f of minus x. But basically what it means is also, there's another way to understand is this this graph, this red graph, the black one, it's like any point. Let's see if there's any point here, and if this point is reflection over the origin. So this point. So if you have A and B here, this becomes minus A and minus B. It means the whole graph, the black one, this black gets reflected, or sorry, gets rotated over the about the fixed point, which is the origin here, 180 degrees in the clockwise or anti-clockwise degrees, and you will see exactly matches the pink. The black will match the pink when you rotate. So what do? You rotate the original function f of x around a fixed point or point of rotation. So that's the point of rotation. Origin is the point of rotation. So you rotate the black graph around the origin by an angle which is 180 degrees clockwise or counterclockwise. You'll see when you rotate this, it exactly matches the pink one. That's what that means. And finally, we want to see how does it affects if there is a, instead of f of x, if it was 2x, uh, how does it affect? So let's see. And for this, I'm gonna kind of change this uh, the x-axis to a little bigger maybe. I don't want so much. Maybe I just want 4. Okay, and maybe I want to make it 5. And this one and minus 3. Okay. You clearly see this was the original. The red one was the original one. And what you see is observe here is okay. The original graph, that means this was increasing from minus 2 to 1. So that's where in the beginning this was increasing, right? The red graph. But now you see this red one increases from minus 1, and this thing, now what is that thing is? It's almost like 1.5. See, sorry, 0.5. That's like 0.5 and 0.5, and this is minus 1, right? So this is the new interval where the graph gets changes to increasing. So how do we get this answer? Now that you know it is minus 1 to half, but without the graph, how do you identify? Now remember f of 2x, this basically what it means is f of I can write it as x of 1 over half. See this? So what that means is there is a, and you can see there is a horizontal shrink like this point, whichever, whatever this 3 is, this was 3. Now it shrinks to, so this point shrinks and moves right here, then that point is 1.5. And you can see there is a horizontal compression. What is it called? Horizontal compression. And by what scale factor? So if you want to know at what scale factor that there is a change here, this changes to here. And the same thing, this point, which was at -2, so this was -2, so this gets compressed to -1. So what's happening is how the, this is that half, this is the half which is called a scale factor. So each of the x coordinates, so half of 3, so the half of 3 is 1.5 and half of -2 is -1. So there's a horizontal compression, and this half which you see here is less than 1. And because it is less than 1, we say there is a horizontal compression by scale factor of half. So the conclusion is, okay, and one more thing, what is this point was, this was 1, right? So this was 1, 1 and 4, but now this point is half. So this is half and 4. So the 1 becomes half. So this one shrinks or compresses to this. So each of this point shrinks here, this point shrinks here, this point shrinks. So there's a horizontal compression by scale factor of half. So all you do is you times half to all the x coordinates. So I'm concluding now. You see this. So here it is. I already did that. Let me see if I can cut, copy, paste, and bring it up. Mm, and bring it right here and put it right here so that we can compare what's happening. Okay, there you go. So we are more concerned only about this part. See. So okay, so I'm doing the last conclusion. So what this is f of 2x right here. So which I wrote it like x over half, and this is that I say is the scale factor. So every x coordinate is multiplied by half. So this was the original 1 and 3. So each of this is times by half. Can you see half? So everything is multiplied by half. That's all you do. So if this was the number, I multiply by half of -2, and you can see the answer is -1. Half of 1 is, here it is, half of 1 is half. Then this means half of 1 is half, and half of 3 is 3 by 2, and you're done. That's all it is. I'll take one simple example just to make sense. Okay, this is the last example I felt like to show. Let's say there was an original function, and it doesn't matter what function it is. They did give us that the function is increasing from -4, -9 to -4, and then also it increases 1 to 7, and it's decreasing -4 to 1. And just imagine if there was a question here. What if the question was asked? So the first question could be, what is f of x plus 7? Now remember there is a plus 7, there's a vertical shift here by, that means the graph moves up. So what's going on is this will remain the same. It does not affect. So the increasing interval and the decreasing interval will stay the same. And the same thing if I had to write f of x, and let's see if we multiply by half, 1/3 here. So what's going to happen is there is a scale factor of half. This is called uh, vertical compression. So it does not affect. See, whatever the number here, unless, of course, it has to be positive. So if it is positive, this interval will continue the same and it does not affect the increasing, decreasing intervals. They will stay the same. Let me take a new one as f of, let's say f of x plus 5. So what's going on is how does the increasing interval change? Is remember there's a plus 5. It means it is x of minus 5. The h is minus 5. You're moving left. You're moving left by 5 units, right? So every time each of this number you have to subtract by 5. So that means minus 9 minus 5, then minus 4 minus 5, and 1 minus 5, 7 minus 5. So this is how you're going to get the answer. And this side you do the same thing, minus 4 minus 5, and 1 and minus 5. So this answer will turn out to be negative 14, negative 9 union, and this will be minus 4 and 3, and this will be minus 9 and then minus 4. I'm just giving an example. I may be making a little mistake here because I'm trying to finish it fast. The main thing I wanted to show is, yes, as I said, the important one was what if it was minus of f of x. So it's reflection of that. We just have to swap this. That negative 4 will just move here, and this thing will move 9, minus 9 minus 4, union 1 to 7. You're done. But the problem is, what if it was, so what if it was f of minus reflection over the y-axis? So that's where you have to be very careful. This will swap, but it will swap and switch. That means this is negative 4 and plus 1. So you have to swap, that means minus 1 and switch. So that becomes, and the minus 4 will change to plus 4. And this one, what I'm going to do is I'm going to use this power first because of the order. So 7 will change to minus 7 minus 1 union, and union this minus 9 and 4 will become 4 and 9, and you're done. But the same thing, what if it was f of minus x? How do you do? So you just have to swap and switch this number. Then minus 9 and 4 or 1 and 7 will become minus 7 and minus 1 union. This will become plus 4 and 9, and you're done. It's so simple. And this will switch to minus 1 and plus 4. You swap and switch. That's it. So the goal of this, my lesson was just, can we do this so quickly like this? That was the main thing. And the last one is, okay, how does increasing and decreasing interval will change if this was, let's imagine if this was 0 point, I'm just let's say 0.25x. What does that mean? Okay, all you do here is it's a little work. You want to know how much, what is that? Divide by this 0.25. I can write it as 1 over 0.25. See, of course, you already know what I'm saying is the f of 1 over x over 4. That's it. So that's the 4. So you could directly write this as f of x over 4. So the scale factor is 4. So the scale factor is 4. Okay. So that means that's the 4 you're going to multiply to all this number. This 4 is greater than, this 4 is greater than 1. So there is a horizontal stretch, or it gets pulled up horizontally stretched by scale factor of 4. So everything is gets multiplied by 4. So this thing will become 4 times 9 is minus 36. 4 times this is minus 16. Union 4 times 1 is 4, and 4 times 7 is 20. That's it, you're done. And the same thing, 4 times negative 4 become minus 16, and 4 times 4 is, and you're done. That's all it is. So basically is even though there is a 0.25, basically it becomes over 4, and that's the scale factor. Remember that when you have f of x of c, that c is the scale factor which you multiply to the to all the input x. And I hope this video will help. Thanks for watching. So the goal was just to create formulas. How does transposition of the function affects the increasing and decreasing class interval? And that's why I made a nice table here. And I want to show the view it full screen. And there you go. There you go. So this is the full screen of the increasing and decreasing. All this will help. Thanks for watching. And next time I'm gonna any concept similar type, I'm gonna try to make these videos to help a lot of students may be having issues. How do we know how do we know to get the answer quickly? Thank you.